All right, good morning, Enrichment. So we're going to get started on this module to review. You do have extra credit opportunities here, so hopefully we choose to use them. So this is about Module 2, like I said, and this first section we're going to be writing the equation for each graph. So remember, when we write an equation for the graph, this particular graph, this blue one here, is linear. Okay, so it's because it's linear, we're going to use this equation y is equal to mx plus b. So that means we have to figure out our b value and we have to figure out our m value. Well, our b value is where the graph passes through the y-intercept, okay, y-axis, which makes it technically a y-intercept, and it passes through right here, and it passed through there at -2. Then what we have to do is we have to figure out the slope, the rise over the run. So in order to do that, I have to plot another point in order to figure this out. And when I plot this point, I need to be able to plot this point at where my graph passes through the intersection of two grid lines. So what I'm going to do is I'm going to follow this graph. And then right here, I'm going to draw a dot because this is where it passes through the grid's intersection. So that's my next point. So this is going to be written as a fraction, this slope. And in order to figure that out, we have to figure out the rise over the run. So to go from blue to orange, well, going from blue to orange, I go up 3, and going up is a positive thing, so that's a positive rise. And then I go to the left 1. Well, going to left is a negative thing. Now, you have two options. You can do the math for this in your head, 3 divided by -1, or you can use your calculator. And if you use your calculator to make a fraction, you have to hit the green alpha button, in the top left, the y equals button, then enter. And that will pop up a fraction bar on your calculator screen. Then at the top, you'll type in a 3, and then when you click down to go to the bottom of the fraction, make sure you choose -1. The negative sign is right next to the enter button. Do not use the subtraction sign, which is above the plus. Okay, you have to use that negative sign next to the enter button. And when you do, whether you do it in your head or use the calculator, this simplifies to a -3. That's a negative sign right there. So we have all the information we need now for our graph, or to write out our equation. So we have y is equal to -3. That's the m value. Don't forget your x. And then we have a plus -2. Now, is it okay for us to write a plus -2? It is not. So we're going to get rid of that plus minus, and we're going to write just a -2. So our final answer is y is equal to -3x minus 2. Now we're going to figure out the equation for this second graph here. Now this second graph, when I look at it, it is an exponential graph. It curves up. So I know that I'm going to do some type of multiplying here because we're talking about exponentials. So the first thing you're going to want to do, just like we did previously, is we're going to find where this graph passes through the y-axis. And in this case, my graph passes through the y-axis right here at 5. Then what you're going to do is you're going to scoot over one grid and find where the graph passes through at 1. Well, it passes through at 1 over here, up at the top here where it says 10. Now what you're going to do is you're going to take these 2 points that we plotted out, and you're going to write them in a table. So this blue point that we drew out, its x value is 0, and its y value is 5. This orange point, its x value is 1, its y value is 10. And those are the only 2 points that we figured out, or that we were able to find. Now, because we said this is an exponential, we're multiplying. So 5 times what gives us 10? Well, that's a 2. Okay? We have everything we need now in order to write out this equation. So we have y is equal to, well, my beginning value where we started at was a 5. So I'm going to write that 5. Then we multiplied by 2. And then our variable, we'll make this the light blue, our variable, because we're using y's, our variable will end up being an x. And it'll be just an x, not an x minus 1, not an x minus 1, because our table here on that left side started at a 0. So that is why we only use an x, okay? And that is our final answer. So now we're going to graph the equation y is equal to 3x minus 2. Okay, so this is in the form y is equal to mx plus b, which means it's a linear, so we should be able to make a straight line here. Now my b value in this in this equation is -2. And that -2, we should know from earlier, is where we plot our graph on the y-axis at -2. Our m value for this guy is the number attached to the x, so a 3. But this 3 tells us how to move. We need to have a rise overrun. We have to have this written as a fraction. Right now it's not. So whenever you have a whole integer like this that's not written as a fraction, to make it a fraction, you just put it over 1. Now that 3 on the top tells us to go up, and that 1 on the bottom tells us to go to the right. So from my light blue dot on my graph here, I'm going to go up 3, to the right 1, and plot a dot. So I'm going to go up 1, 2, 3, to the right 1. I did the entire movement, so now I can plot a dot. I go up 1, 2, 3, to the right 1. I did the entire movement. I can plot my dot. And I'm only going to ask you to plot 3 right here. If you want to do more, you're more than welcome, but all I'm asking for is 3. So if I connect these, they do make that straight line because this is a linear equation. So we got it. If you want to double check that, that's absolutely fine. Okay, so now we're going to graph y is equal to 3 times 2 to the x. So in order to do this, let's look back over here at this graph, this second graph that we plotted, okay? We got this 5 from my y-intercept, or where my graph passed through the y-axis. We got this 2, right? Because it told us what we multiplied by down our table. So using that information, if we have y is equal to 3 times 2 to the x, okay, I'm going to make a table of values here. Well, this 3 is going to be where my graph passes through at the y-axis. So it's going to be a 0, 3. And because I already know this is where this passes through the y-axis, I can just plot that dot. Then this 2 is what we're going to multiply by down our table. So when I take a step, I have 0, 1, 2. 3 times 2 is 6. 6 times 2 is 12. And that's all I'll ask you to do. Then we're going to plot these dots here. Well, I have to plot 1, 6. So in order to do that, I'm going to start at my origin here at the middle, go to the right 1, because that's where that 1 comes into play. Go to the right 1, go up to 6, plot a dot. For 2, 12. This is going to be my x value. This is going to be my y value. So I'm going to go over to 2, go up to 12, plot a dot. This is an exponential equation, so I'm going to draw a curved line happening here. Okay? The next thing we're going to do in the next slide is we're going to do the first two, write the equation for each table. Okay, we're going to write the equation for each table. So looking at this first table here, we go from 2 to 0, 0 to -2. So mathematically, what we're doing down the table is we are subtracting by 2. And because we are subtracting by 2, this is a linear equation. And linear equations do not have exponents. So we're not writing with an exponent. Now, it seems like many of us prefer y and x's, so I'm going to write the equation. Y is equal to, and then the rest of my expression will use a variable x. Now, we have everything we need in order to write this equation. And I know you don't believe me, but we do. The first thing we're going to do is we're going to write that minus 2, that green minus 2. Okay? Then we're going to have this variable x next to the 2, because your variable is always going to be next to the value that you use to go down your table. It'll always be next to that every single time. No ifs, no ands, no buts. Now, when I look at this table, however, my table on the left side in the x column starts with a 1. Anytime it starts with a number other than 0, we have to do x minus that number. Well, in this case, it's a 1, so I'm going to do x minus 1. But we're not done looking at that first row. We have to write out its partner here. Now, its partner is where we start. We start with a positive 2, so we just write plus 2. Now, this is our final answer, but I want you to think back to Module 1. When you think back to Module 1, when we used f of n equals, well, we always wrote the start value in the right column first, which in this case was that pink circled 2. We always wrote that first. Then we would write what we did down the table, which in this case was minus 2. And then we looked at our x value. And again, our left column, and in this case, we would use n's instead of x's, and this would have been an n minus 1. These two equations mean the exact same thing. The only difference that's happening here is we flip-flopped the placement of where we put our beginning value and then where we put our, what we do down the table and the x. Okay, we just change their locations. And this one uses y's and x's, and this one's use f of n's and n's. But they mean the same thing. Okay, so basically we took Module 1 and we kind of did more stuff with it during Module 2. But as soon as we started using some crazier words, I feel like a lot of us struggled a little bit. So these mean the exact same thing. Okay, this is just written as a linear form. With the f of n, it's written more like a arithmetic form. So now let's look at the second the second table here. So how do we get from 2 to 6, 6 to 18? That's the same. Well, we're multiplying by 3. And now we have everything we need in order to write our equation. So again, our equation, we'll use y's, and we have y equals, well, again, we begin with a 2. We multiply that 2 by 3. How many times we multiply by 3 is unknown. That's our variable. Our x goes in the exponent here because we are multiplying. This is an exponential equation. Now, it's not going to be just an x because, once again, this table starts with a 1. So we have to do x minus 1. Okay? And that's our final answer. And this is how we would write it, too, if it was a geometric, except we would use f of n's and n's. So we'd have f of n is equal to 2 times 3 to the n minus 1. That's how we would write it for a geometric. All right. Many of us chose to make these next two problems part of your extra credit opportunities for your class today. So each one that you get correct, you'll get a point. Now, if you don't know what these are, this is how you graph point slope. So if you need help with that, use the YouTube, graph point slope. That's what it's called. Now, what we did focus on is simplifying equations, which is these left two problems. Now, again, these right two problems are going to be extra credit. Okay, so if you do them, great. If you don't, that's fine too. If you want to boost your grade up, do this. So let's talk about simplifying. When we simplify an equation, the first thing you're going to do, well, first, we have only learned how to simplify linear equations. And both of these are linear equations because the variable is not in the exponent. Now, when you simplify, the whole goal is to get rid of the parentheses and combine all like terms. In order to get rid of the parentheses, you have to distribute the number in front of the parentheses into everything inside of the parentheses. I feel like I said parentheses a lot. So for this first one here, I have 2 in front. I'm going to distribute that to the n and the negative 3. And when I say distribute, it's just a fancy different way of saying multiply. So we have 2 times n, that's just 2n. 2 times negative 3 is negative 6. We didn't change anything else, right? So we didn't mess with that minus 2 in the back, and we didn't mess with f of n equals. And we are not going to mess with f of n equals, so I'm going to rewrite it. Now what we're going to do is we're going to combine like terms. In order for 2 terms to be like, they have to either both have the exact same variable or they have to have no variable. Now when I look at this problem, this 2n minus 6 minus 2, minus 6 and minus 2 are like terms. Now when you combine like terms, it means you add or subtract them. So what you can do is you can either type into your calculator negative 6 plus negative 2, or you can type negative 6 minus 2. Or if you are good with your mental math, negative 6 minus 2 is a negative 8. We didn't mess with that 2n. It doesn't have any like terms. It's a lonely guy, so that just stays 2n. So our final answer, simplified, is f of n is equal to 2n minus 8. Now we look at this second one. We have f of n is equal to negative 3 times the quantity n plus 4 plus 10. So once more, I'm distributing that number in front of my parentheses. This negative 3, don't forget the negative. And distribute, once again, is a fancy way of saying multiply. Negative 3 times n is a negative 3n. Negative 3 times positive 4 is a negative 12. I didn't fiddle with anything else, so everything else stays the same, that positive 10 and f of n equals. I'm not going to mess with f of n equals, so I'm just going to rewrite that. Combine like terms. My like terms here are negative 12 and plus 10 because both of them do not have a variable. Negative 12 plus 10 is a negative 2. We didn't mess with 3n, negative 3n, so it just stays a negative 3n. So my final answer here is f of n is equal to negative 3n minus 2. Once again, those last two over here are extra credit if you want to do them. I hope you guys have a wonderful day.